Good day. My name is Bendik Semeulemeester and I work as a business development director for UMICORE Electro-Optic Materials. And today I'm going to tell you a story about germanium and the strong link this material has with silicon and gallium arsenide. So, who is UMICORE? Our roots are European, but we are active globally in materials and recycling for clean mobility, such as automotive catalysts and battery materials for electrical vehicles. We are uniquely positioned with ties to both the upstream resource chain on the one hand and the downstream technological applications on the other hand. Our focus is on sustainability and is recognized internationally. We hope to contribute to a worldwide balance between the available resources and the needs of the industry. Our 11,000 employees active in clean mobility, precious metals recycling, and electronic materials. And as a financially healthy company, we invest heavily in material innovation. So, as part of our electronic materials business, UMICORE offers solutions for the electronics deposition technologies such as CVD, ALD, MOCVD, for instance, TMG and TMI materials, or electrochemical deposition for 3D packaging, for instance, or PVD sputter targets. But today our focus is on the semiconductor wafer activities, and notably germanium substrates. So silicon and germanium are chemically and physically very similar. They share compatible basic chemical compounds such as silane and germane, which make production of optical fibers and silicon germanium electronic devices possible. Silicon and germanium, they also have the same crystal and wafer production methods, and both have large size wafer, 8-inch and 12-inch capability, with perfect crystallographic quality and zero dislocations. Our first 8-inch and 12-inch germanium wafers have been produced already more than 15 years ago. If we compare to gallium arsenide, germanium actually acts as a bridge with silicon, the silicon world, and the gallium arsenide photonics world. The main application of germanium wafers today is actually multi-junction gallium arsenide solar cells for space applications, and UMICORE has an annual capacity of more than 500,000 6-inch wafers. Now, a couple of years ago, IQE discovered that germanium has a better lattice match with gallium arsenide, aluminium gallium arsenide diffracted Bragg reflectors from the VCSELs, and they exhibit no bow, therefore, and no stress, and that is impacting the yields in a positive way, which is typically a problem in VCSEL production. Let's say this is a very short presentation. To conclude, we say the germanium wafers are a very good option if you're fabricating VCSELs or looking at integrating your photonic devices with silicon, or if you want to lower your production costs and you care for the environment. Our 6-inch wafers are readily available. If you scan the QR code, you can get in touch with us for a quote or for some samples. Thank you very much for your attention and have a nice day.